Everybody knows about Maxwell's equation, right? They tell us that there is some fixed speed of light in vacuum. So, if I'm not considering any assumptions about the speed of light is being special, or and let's say the speed of light is just a simple speed like a car moving. So if a car is moving, it would have some velocity, let's say v, not generally c. So in this scenario, you can always find some frame which is at rest relative to this car, right? That's pretty obvious. So if I find such a frame, let's call it S, in which I am static with respect to this v, I mean the car. So I would see that it's not moving at all. And if I apply Maxwell's equation in this frame, let's say v was the speed of light, in the, and it is dependent. I can calculate the speed of light in terms of vector e and b, right? So, and now let's say I jump to this frame S, and that means I should see light paused, right? If there's nothing special about the speed of light, then the speed of light should be paused. I shouldn't see it moving like this car. And if you see this, I mean, then because we know that there are oscillations in the EM wave, so you would see static oscillations of E and B simultaneously. So, and that is not possible actually. Quantum mechanically, that's not possible. Simultaneously, E and B being statistically oscillating is not possible. This is because if you have, let's say you have a static charge Q, and this static charge will be producing a constant E, okay, at any point. So here is no B at all. I am in a static frame, and if I start moving, then I would see the charge Q moving, and moving charge would be producing a magnetic field as well. From this example, you can see that a static charge cannot produce both E and B, which are oscillating, right? So from here you can get some intuition that simultaneously oscillating static fields are not possible if they have the same source, such as this Q. So this suggests that there is some weird thing going with the speed of light, because I am able to jump in a frame which is making the speed of light static to me, and that is not possible simultaneously E and B fields. So this suggests that there is something weird going on with Maxwell's equation. And this is a story of 1890s or maybe 1880s, when people were following the Newtonian velocity addition. Like they were simply adding the velocities as u plus v, or making linear transformations as x is equal to x minus vt and things like that. So doing these kind of transformations, we find that there is something weird with the speed of light, because in the frame where speed of light becomes static, it's not actually possible. So there is something wrong with the Newtonian or Galilean transformations of these velocities. So what are the assumptions with the Newtonian model of classical mechanics? The most greatest assumption is that time is same for everyone, right? So let's strike off this assumption. Time is not same for everyone, and yeah, so that's it. Time is not same for everyone. Let's strike off that assumption, and we are not considering that scale of time is same for every frame. So let's draw a general time versus space coordinate of some, let's say, some frame S. Okay, there's some frame S having coordinates S, T and X. So anything moving would be like this. X, let's say x equals vt, right? The simple object which is moving would have a trajectory like this at constant velocity, and some v dash greater than v. Speed of light would be somewhere here, ct. I don't know, but I know that c is a very great speed by experiments I know. So some greater velocity would be here. Okay. So to make things simpler, let's assume that derive equals 1. I'm setting in my some frame that c equals 1. Okay. It's just a simplification. So if I'm setting c equals 1, then let's say I'm taking time in seconds and I'm taking x in light seconds. Okay, there's no flaw with that. So if I'm doing that, if c equals 1, then x equals ct would be x equals t, right? Okay, so that would be line at 45 degree. That's clear. So now let's just take two frames. One is this S frame having coordinate t and x, and let's take another frame having coordinates t dash x dash. For simplification reasons, I am taking I'm just taking the motion in one dimension. Okay, just for simplicity. We can generalize it later on in other coordinates as well. So any other velocity, let's say this frame S dash is moving at velocity v. So it would look something like this. X equals vt. As soon as this v will increase, it would be projected upon this. Okay, so it would become x equals t when v equals 1. And let's say there is another frame moving with same velocity and is displaced by this frame. Like I am standing here, then there is a car moving this way, then let's say behind that car there is other car moving as well. Okay, so there are two cars moving with respect to me at same velocity v. So its trajectory would be something like this. Let's say it's 1 unit apart, 1 light second apart. So this is 0, this is 1. So it's x is equal to vt plus 1. Let's say there is another car as well. There is a race going on. There are few cars. This car is at x equals vt plus 2. So let's say for some reason, for some specific reason, I want to see if I do something in my frame at a particular instant of time and at a particular position, and I want to see how it looks like from the other frame. Okay, and so if I have some coordinates of some event E as x and t, and this for the second frame, let's say it's E1 x1 comma t1. I am taking t1 because I am not assuming that time is same for all. And for another one it's x2 comma t2. Okay, so I want to find these x2, t2, x1, t in terms of x and t, and if it comes out to be that t1 equals t equals t2, then Newton is right, otherwise Newton is wrong. So now let's make an assumption. Assumption what Einstein did exactly, we are going to make an assumption, and if that assumption comes out to be true, then Newton is wrong and Einstein is right. Okay, and if it doesn't, then if it doesn't. So the assumption is, actually there is only one assumption, that laws of physics are same in every frame. Okay. So if in some frame I am seeing the speed of light as moving at the speed of light, then I should see the speed of light as moving as the speed of light in other frame as well. Or in other words, what I presented initially, that there was a frame in which light was static. So that shouldn't be possible, right? Light shouldn't be static in that case. So light speed of light will be speed of light in every frame. And I want to prove to you that if speed of light is constant, let's say speed of light is constant, which is my assumption, then it is the maximum speed as well. That would follow from this only. Okay. And how that will follow, we will see in a while. So if the speed of light is constant, which I am assuming, this is my only assumption for a while. So I want to know these coordinates x2, x1, t1, t2. So what do you think is the best way of doing it? If I want to find these coordinates, let's say this is some point, this is some point. So what Einstein suggested was that since the speed of light, which he is assuming to be constant in every frame, he can use that speed of light to calculate the coordinates of simultaneous events. If at this point for frame S, things are occurring at 0, 0, so he wants to know that what would be the corresponding coordinates in frame, let's say this S1, which is moving at some velocity v and having coordinates x1 and t1. So what does that event would correspond to in this frame? So what he suggested it was that you take the speed of light, and let's say there are two parties, and I send some signal to the other party at the speed of light, which is constant in every frame. Okay, so I did some event here, and then speed of light went there. So he can precisely calculate the timing by reducing the time which light took to reach him. Okay, so he can know my coordinates, because if you would have been using something else in place of speed of light, then that speed wouldn't be universal, that would change, because you can find some coordinate which has that speed as static. So since the speed of light is constant, I can use the speed of light as my medium to make connections between different events. So at t equals 0, this some party sends a beam of light. Okay, then it reaches the other party here. Okay, this is a very general x and v diagram which I can make. So here's some coordinate, let's say xa comma ta, and now there is some other party as well, forward to that party, who also wants to synchronize the clocks, who wants to know the precise coordinates of simultaneously event t and x. So that party is also sending some beam of light to this party, okay, to get the coordinates. So this is all the speed of light moving in the forward direction. Then there would be speed of light moving in the backward direction as well, whose slope would be -1. Okay, because I am taking c equals 1. So if I make a line from here at negative slope, it would meet somewhere here, not exactly to this bottom. Okay, so from this I have another coordinates xb comma tb. So for connecting this point and this point. So here, if you look at this line, so this line is saying that 0, 0 is the point of some event in this frame, and x, a, t, a are the coordinates of that event at the same position. Okay. So there would be a difference of time, because here time was 0, in this block time is ta. So let's say what are the coordinates xa and xb. And similarly, there is other line for this other B frame. So for this also, if some event occurs at 0, 0, it would occur at the same position, at some time tv. This much is clear to everyone? Any confusions? Yeah. This line. This party was sending some beam of light, and that slope would be equal to 1, right? Because I am taking c equals 1. So this is the trajectory. This is simple. There is some coordinate this. Okay. Now this B party wants to do the same as well. So B party would also be sending a beam of light. And if you are drawing the, see, because this was the spiral light in this direction, in the plus direction. So equivalently, if I project it back, there would be spiral light in the backward direction, having trajectory like this, and slope -1. So this is the exact thing I did here. If you would have projected this here, it wouldn't meet at this point. But I want some point to be common in every frame, so that I can compare the times. So that is this line. So I have a coordinates xa, ta, xb, tb, and that is at equals t. So doing simple math, how do you think we can find this point xa, ta? So at this point, xa would be equal to ta, right? Because it is lying on this line where x equals t. So xa equals ta, this is one equation, and from here it was x a equals bta plus 1. Or I can say ta equals 1/1 minus t, okay, which is equal to this xa, because from this equation. This simple math, no physics we are using here. And now we have to, okay, we got x, a and ta in terms of something which everybody knows. Spirulite is known by, this is P is known to everyone. So we get ta and xa. Now let's try to find x, b and tb. How we can do that? First of all, let me write down x b equals vtb plus 2, okay, and apart from that, what do I know? And what? X plus v plus t. Yeah, v plus t is equal to some constant k. Alright, to find the value of k, I can introduce these coordinates. So this would become, if I introduce xa and ta, which is equal to 1 over 1 minus v, so it's equal to 2 over 1 minus v, and so then xb, so from here xb would be equal to what, and tb would be equal to what, quickly, xb would be equal to 2 over 1 minus v square, and tb, yeah, I think that's correct, 2b over 1 minus v square. Okay, so I have these coordinates as well. So TB over XB would be equal to the slope of this line. This is theta, so, and that is equal to V. So I can say that this line was equal to T is equal to XV, and here was the line X equals VT. So this slope and this slope would be same, right? We did not do any physics, we just did simple algebra. So in a way you see that initially the coordinates were these coordinates, and when I started moving, there was some contraction. Okay, there was some contraction of the coordinates, of the axes. They are no longer orthogonal, because this x equals vt was the frame of someone moving at v. Okay, and this was the other party moving at v as well, having the same event coordinates 0, 0. So if you project them back, they meet at a single point having same coordinates. So that means this coordinate had the same value of x and t at this point of time. That means this event was simultaneous in every frame. Okay, having same space-time coordinates. And the corresponding simultaneous space-time coordinate, when they had the same position, not time, was this xb comma tb in the b frame, and this xa comma ta in the a frame. Okay, so from this, what we conclude that whenever there is some something moving at some speed, there is some kind of linear transformation. And linear transformation, now you know, you have studied vector spaces. So there is some kind of linear transformation which is connecting the coordinates. Okay. So taking a very, very general case. By the way, if you want to introduce the speed of light here, how would you do that? You can just match the dimensions and put c wherever required, because the converse was the case. So you can everywhere put t, v by c, v by c, v by c square. And someone was asking frequently that if speed of light is constant, why should it be the maximum as well? From here we can see that. If we have, in a while we will see that this kind of function would restrict the speed of light. Something being more than the speed of light is constant. So note down these coordinates. Any confusion until here? So now forget these Vt plus 1, Vt plus 2. I am not taking so many bodies here. I am just taking x equals Vt. So very generally I can write down the transformations equation. Let's say now this is a frame S dash and there are only two frames, nothing like these other frames. So now I have three things. One is this x equals Vt. The other corresponding line would be t equals Vx. This would be here, let's say. And this speed of light as usual. So now the question is very simple, that if I can calculate x dash and v dash in terms of x and t, then I can find any coordinate for any moving frame. Yes, that's simple. So I know that x dash equals 0 whenever x equals Vt. Okay, this is x equals Vt, and the corresponding x dash would be 0. X dash is the coordinate. So if I jump to another frame, I would always say that I am at the origin, I am not moving, right? So x dash equals 0 when x equals Vt. So I can take x is equal to x minus Vt. This is, and for the very general case, let's say, because this was the Newton's method, right? And all my laws should reduce to Newton's form in some limit as well, otherwise I am wrong. So let's say there is some other function, some function beta, let's say multiplied by some factor beta. I don't know what beta is, I have to find that out. And what function of beta can be function of what? Anything else other than velocity? It might be a constant, but generally what it could be a function of. The only thing that matters in this is the velocity, right? So it has to be a function of velocity. There is no other possibility which I can think of. I don't know if there are, there may be, but I don't know. This is the only one I can think of right now. And doing the similar transformation, see, this was x equals Vt, and so this was the thing when t was simultaneous, right? T was same for both the frames, and this is the corresponding line when x is same. So I can write t dash equals y minus y naught plus. Those who have watched that lecture before can tell. There is no other possibility. It can't be. See, I am taking the speed in some particular direction, right? So my coordinates should transform in such a way that these conditions are satisfied. T dash equals 0 at this position and x dash equals 0 at this position as well. So here also doing the same thing. I don't know this function, so this function maybe some beta of v, not just beta, okay, that's let's say some gamma of v, some alpha of v. This is the more general case. I don't know what this function might be, but the only information I know is t dash equals 0 when t equals vx. So the only function which I can think of is of this form, right? So we can get every information about x and x dash and t dash if we know alpha and beta. How do you think we can find alpha and beta? What? Yeah. Okay. Apart from that. Anything else? Yeah, but you are right somewhere, because until now I didn't use my assumption. So I think I can use my assumption, and if it okay, so what I know is that how these coordinates would look like in the light's frame, right? In light's frame, everywhere x equals t. So let's put x equals t equals x dash equals t dash. Everything equals 1. Okay. So x equals. So at this point I am putting a particular coordinate in light's frame, 1, 1 in all these equations. So 1 equals 1 minus v times beta, and 1 equals 1 minus v times alpha. So alpha and beta must be equal. Putting speed of light. So alpha equals beta now. Okay. I'm rubbing this part. So this was x in terms of, x dash in terms of x. Now let's see how I can do a similar thing from the other frame as well. And so if I am moving with respect to you at v in some certain direction, you would see me as moving with minus v in the other direction, right? So this is quite intuitive, that I can form a certain set of equations which are similar to these by just changing the sign.